Let's try this. Hello. All right, better? Okay, great. All right, nice to see you. Okay. Going to talk about TensorFlow.js, and then a little bit about the Edge, let's say. I did talk about TensorFlow.js back in June with Chris. It just came out. I sort of like stepped through how TensorFlow.js works and everything else, but I didn't really do any demos. I didn't really show off any code. So I challenged myself was to try and actually prove that I know how this stuff works. And so we'll discuss whether or not I actually got there. That's my goal here for this presentation. My big point I was trying to make in the last one was basically that JavaScript is sort of, kind of not the cool language for machine learning, I would say, for the most part. And it's kind of like the skate punk kid of programming languages or whatever we'll say. But I think you need to have it on your radar because JavaScript is just, it's kind of forced to be reckoned with. So then we'll look at some of the stuff that's happened since June. And then I'm going to show you my semi-working TensorFlow.js plus CloudFlare demo. I still like this picture. Most of you, if you do data science and stuff, you probably do Python or R. A lot of people end up doing Java for production-heavy stuff, and then we got to deploy it. Like I said, I like the little keyword guide for JavaScript because oftentimes I feel like JavaScript is kind of like this, Frankenstein monster of things that are combined together. And then you have your Haskell, your purity of language, et cetera, et cetera, et cetera. And then I'll even give a point to the little, with enough semicolons, a list programmer can move the world. So everybody gets a shot at it. Very broadly, this is how I think about the different levels of this stuff of approaching these problems. At the highest level, I think you can think of machine learning as being just your CPU plus whatever tools you have, math at a very high level. In the real world, though, you're probably going to have to use some sort of virtual machine with a GPU in order to get your performance. So that's where you get into GPU notebooks. The next level up from that, then I think, is orchestrating full-blown cloud server deployments. So we'll just say units in some form are there. I'm a mobile programmer. That's what I've been doing for the last, better part of a decade now. So mobile, iPhone and Android devices are definitely my bread and butter. But I think of any embedded environment. You take a laptop and put it in front of a car, and you have your self-driving car, right? But, it's this. I think this is harder because with the cloud you can oftentimes throw resources at a problem, whereas if you're working on a mobile phone, you have very hard memory, CPU, and energy constraints. Next one then, I think, is custom hardware. This is ASICs, and this is what a lot of the hardware and machine learning startups are doing right now. This is the very, very leading edge of all this stuff. But today we're just going to target level 3 here. Yeah. Another comic. Yeah, they got this comic. They got they do 8 different programming languages, but I like this one because the guy sets up the node and everything else, and then the packages are obsolete. That's oftentimes how this works. And yeah, this one will be even funnier here in a minute. So hang on. The broad point I was trying to make, I think, in my last presentation is basically that I think JavaScript is this 600-pound gorilla of programming languages. It's just all these people who are trying to learn HTML. There's all these people who are trying to make websites. They're always just doing crazy stuff. And a lot of, quite frankly, nutty stuff comes out of the JavaScript world. But the flip side is because JavaScript has this crazy pace of innovation and steals ideas from literally everywhere, I think it's probably the programming language that today is literally the most, evolving the fastest. I think it's been that way for at least a decade now, and all these other companies with plans and all this stuff. In the end, it just comes down to random web developers here and there. Yeah, every few months, literally the JavaScript universe changes. And, literally it goes forward, sometimes it goes backwards. We can say Apple is maybe 2 generations ahead, 3 generations, 3 one-year generations. But I think that JavaScript is going to catch up eventually. Okay, yeah, last time I did do a lot of demos. So here's some demos I found on the internet that I thought were pretty cool. So we'll just jump through them. This is a nice little one. It downloads the NS data set and then runs it in real time here in the browser. You can see your little loss curve and your training thing. We get to the end here. Shows us all its predictions. Here's a 5, but 8 kind of looks like a 5. So you can kind of not get too angry at your categorization algorithm because it's doing its best. This is a cool little demo, but it mostly only works in Chrome. Let's see if it loads. Okay, so this is a webcam, and it's running the YOLO object recognition network, so you can see it's tracking me, right? So, yeah, cool stuff. Yeah. This is Magenta, which is a Google audio art sort of project. And so I don't know if this is going to play the music. We'll see. But do you hear anything? No? It's basically playing this randomly programmatically generated music. Oh, this is just okay. This is a demo of how GANs work. And I thought it was cool because it kind of visualizes how the data sort of starts off as random, random initialization state and slowly starts to spread out. I don't think a lot of people I personally cannot, mentally conceptualize how GANs work. So this is kind of a cool way of looking at it, just in the real world. Okay, and this is one I saw last week, but I thought it was pretty cool. I'm not going to actually demo it for you, but they took mobile nets and then retrained it to recognize gesture or input. So basically, sort of punch in the camera, convert your motions into actions in the actual game. So you can sort of virtually kick punch fight with your friends or whatever using this. So I thought this was just a cool putting all the pieces together demo. yeah, this is a paper from May, I'm going to say, or so. It's called Astronet. This is more like traditional TensorFlow as opposed to TensorFlow.js, but I thought this was a cool paper. The top two columns are sort of what a light curve from an ideal star would look like. So we have like this little dip over here, and that's basically a planet passing in front of the sun, you know, and we're detecting the change in the magnitude as it passes between the star. So again, the second column is like sort of a, let's say that bump with a more, just that specific notch over the signal, if that makes sense. So the second row is what a real-world planet finding thing would more likely look like. There's literally this one little dot over here. That's the only actual sample that the camera's picked up from the star. And so basically they're trying to train a neural network to define these outliers, you know, say is this noise or is this a real signal, so then they can go back and like, you know, get more signals from the star, where then they can actually see the planet passing over the star field. So then, yeah, you get like this, say this random dot, you know, you detect it, you figure out that there's actually a planet there, and then you can update your gravitational models of the star. And so basically then you can start to find these like second order perturbations, which means that you start to find other planets around that star. At the end, that like, you know, you find one, and that's your stepping stone to finding another. And that's how they come up with this whole like clusters. Yeah, this is a cool paper. All the code is in the TensorFlow/models demo directory, so you can go look at it and see how it works. Yeah, here's some other stuff that's happened in the last few months. NVIDIA has shipped Turing. CUDA 10 is out. I upgraded my stuff. It's still slower than PyTorch 0.4.2 and everything, but you know, you should be aware of PyTorch and FastAI. She's got Horizon. It's going to come out shortly. TensorFlow 1.11 came out. Eager execution is the big thing for TensorFlow this year. It's on the roadmap for TensorFlow 2. I'm going to do a talk here in a couple weeks on Swift and TensorFlow. We're going to do this a whole bunch. And then, yeah, the start of summer, iOS 12 was in preview. It's been launched, so time to start updating their apps. Obligatory XKCD comic about JavaScript. So this is the demo I wanted to do. We'll phrase it like that. I didn't quite get there, but I'll explain here like where I fell down or whatever. What I want to do is take TensorFlow.js, use a MobileNets model. MobileNets is like a very small CNN, so like 17 megabytes for all the data. So that makes it easy to ship down the wire to like run on a phone or something. Then spin up a cloud worker using Docker, and then use CloudFlare as the proxy layer. And then finally, I wanted to do like a kick-ass serverless deploy to do all this stuff live for you. So the first part of this was actually the easiest, ironically enough. I went on the internet. I went on the internet, and this gentleman, James Thomas, who's a developer advocate for IBM, has written this whole MobileNets JavaScript CloudFlare thing right here. So you should go read his blog post, but basically you can walk through here. Here's what I was wanting to do right here. Wham, outputs the results. he walks through all the tricks right here. This is one of the tricks right here, building this Docker file. And then this is what the actual MobileNet's TensorFlow code is like. It's a little bit larger on screen, but it's pretty understandable, I think. And then there's a little somewhere in here. It's the package.json file, so it pulls into the libraries. So then, yeah, mess around with the. Yeah, look at this. So I got like the CloudFlare routes things working, which is pretty cool. Basically, you can define like a little bitty JavaScript worker. This is like the YAML config file. You build up a little package file like so. And then this is what your actual JavaScript file looks like. So, okay, this is what I had, right? This is what I had, right? So we like make this change, let's say. And then, oops, then we run our serverless deploy. It packages everything up, ships it off to the server. We come back over here. It takes it like a few seconds to kill the old workers. There you go. So when, but when, then yeah, you have your workers running in the Cloudflare things. Like you said, they got 150 nodes or whatever, so everything's running in in theory, semi-locally to you to get the optimal performance. So I attempted to get all this working with CloudFlare, but basically there's some peculiarness of the whole process. His implementation is tied to the like Docker runtimes, which IBM apparently is like a custom thing that they ship as part of their open risk implementation. So it's sort of like using like one of their platform tricks that they use demo. So to move it to a different system, you have to rebuild that whole ecosystem. So I started messing with it. I mean, I'll promise that I can get it eventually, but yeah, right here, right now, it's not working. I had a bunch of help off the internet from a guy named Sean Graham, who helped me figure all this shit out. So I want to throw a shout out to him there. But hopefully here in a week or so, we'll get the Docker thing deployed, and then we'll maybe like a CloudFlare proxy worker to manage the requests, and then I'll push it out, and all will be well and good in the world. But yeah, that's what I tried to do, and didn't do quite good with it. TensorFlow.js mobile, that's part definitely works. It's just all this freaking JavaScript package.
So can you show the CloudFlare framework or whatever GitHub project?
Oh, sure.
There's like a base project that you extend back to be deployed to CloudFlare, and CloudFlare does something.
Yeah, there are a bunch of examples up here of how the pattern is supposed to work. Is that what you meant, or something else?
Yeah, there's one that's like base project or something.
I don't know. I mostly just went through their. This was super helpful. Full area documentation, so FYI.
Yeah, you have to go to a couple of different places to find it. It's one of those recipes. Yeah, I guess that's what we have. How about the post requests? Basically ends up just looking like this. You embedded, well, like you can load your own libraries. Like you can do just how you get the TensorFlowJS.
Yeah, this whole thing for embedding NPM, but apparently, currently, the TensorFlowJS, you still have to actually have a library call out at some point in time. You have to call out to an actual library at some point in time. So you can run it locally on your machine, but whenever you think you have to embed that whole, and yeah, that's where it got fun. So.
Oh, I see. This kind of reminds me of the early App Engine days where you think that you had an idea and you go put it out there and then you realize half the JVM isn't supported. Only we knew some CloudFlare people.
Yeah, I thought about coming over here and asking. So yeah, that's basically all that's all I've done. But yeah, thank you for your time. You need this? Yes, tracks.
How do you, so you did the Fast AI program, right? Can you talk about that? For no other reason, just
well, I did a whole part of my presentation is how I teach and learn machine learning. I think there's a handful of things that you can learn. Right now, you guys in Python, I would say it's just mandatory. There's a lot of UAs on the guys in Python still. I tell people to learn a little bit of probability statistics, but not a formal one. So I tell people just to try and pick up from that. If you can actually actively put a stone on the board and predict who's going to win, that's like 90% of the real statistics. I went through the Coursera, the deep learning.ai courses. Those are pretty good. They have a whole Jupyter notebook sandbox that you can work at, so it makes your life simpler. And then the next one up, I think, is to go through Fast AI 2018 micro sequence. I think if you do that one from beginning to end, basically you'll know as much machine learning as you out there. And then after that, you just really start reading papers and downloading one document out of paper off the internet, trying to reverse it each and every day into conclusions as well. If you want to be good at machine learning everywhere, I want you to do it.
Okay, cool.
Thank you.
Okay, cool. So, thank you very much. That was really interesting to see that. Okay, so cool. Yeah, I think I'm in somewhere being recorded. See if we've
Yeah, can you do computer audio and then unmute yourself? And can you mute?
I turn myself off. So.
Join. Okay, so now I'm being recorded. Is that supposed to be, is it working?
I think so, yeah.
Okay, cool. All right. So I've got a lot to share with you. I'm going to try to do it quick. But I think that's nearly impossible. So, but we're not going to go long. Okay. Okay, here we go. Great. So, am I not doing that?
Still has your cute face.
It doesn't let me share.
Like through the Zoom thing?
And this is the Zoom. I'm looking at the Zoom thing. Go back to meeting maybe. Share. Oh, here we go. Okay.
Yeah, there you go.
That's probably it, just desktop. All right, I think now I'm. Is it sharing?
Yeah. Perfect.
Okay, cool. All right, you guys can all see this. Okay, great. Okay, so we're going to talk about two things primarily, and that is Redis streams and Redis Edge. Those are two things. But before we do that, I'm going to tell you guys some stuff about Redis you don't know. And one last time, shout out to Redis Labs, CloudFlare, pipeline.ai, and the EdgeX Foundry Foundation. Here's some things we're going to cover, but let me just get right into it. First of all, you probably don't know this, but Redis is ridiculously popular. Now, one thing I figured out is that if I ask you all right now, the next application you build, are you going to start with Redis as your first database? You're not going to have any hands. Let's do that. How many people are going to use Redis as their very first database for the next application, right? Okay. Well, usually it's like 10% or something like that. So why is, oops. So why is Redis so popular? Huh. I've got it on, hold on a second. I've got it on, it's auto-advancing is what's for some reason on that slide. So why do you think it's so popular? Why is that happening? I can tell you that it's because it's going to be your second most popular database. And that, or I'm sorry, it's going to be your second choice. So as soon as your application begins to scale, tons of people use Redis, right? So you may start off with a SQL database, and there's tons of these SQL databases out there, or you might start off with some other NoSQL database. But that first choice is split up amongst like 10 or 15 different databases. But as soon as you start to scale, Redis is super popular, if not the most popular database at that point. Here, I'm just going to go forward. Okay. So what makes Redis so popular? Number one, it's the performance. That's what people love Redis. Number one, they keep coming back because of the speed. Number two, it's these Redis data structures, and that's the thing I'm going to spend just a few minutes telling you about because that is very interesting, and you probably don't know that much about it. And number three is it's modules, which is one of the other things we're going to talk about tonight. So performance, think about two things. It's not just the response time per request, because when you're dealing with this kind of speed, it's also about how many requests can you do, okay? Because it doesn't really help you much if you get a fast response time, but you can only do a few, 100,000 or whatever, when you need 1 million, okay, requests per second, all right? So Redis can do something called pipelining, which allows you to send 1,000 requests over at a time. It'll process 1,000 requests so fast you won't even notice. It'll process those 1,000 and send them back across the network because the network is what might be slowing you down oftentimes. And so pipelining allows you to have both high performance response time and lots of throughput. Now, here's what I just want to spend a couple minutes on. Anybody know what movie this is from? Exactly. Actually, I think it's from 2010, but they're looking back to 2001. When they're looking inside the monolith, and it's a black monolith, in space, and looks inside and he sees a bunch of stars. And that's kind of how I feel about Redis, because when you look inside of Redis, you think it's just going to be a key value where the value is a string. But it turns out there's a whole bunch of data structures. And there's 10 of them. And I just want to let you know you should look at these, because each one of these data structures is built for the performance of a particular type of response that you're looking for. So once your database starts to slow down and running into trouble, there's a data structure probably for that performance problem, right? So a very simple one, of course, is a string, and that's where you might simply do a cache. There's another one called a hash, which is a string, but it's broken up into field value, like a row in a table. You can use that for storing sessions in your database. I'm sorry, for your application. And if you think about it, should you be storing sessions in a SQL database anyway? Do you need to run a SQL query to look up a session? Cookie value or user ID, look up online or not. That's key value. There's no reason to do an SQL query for that. On top of that, do you want that on disk anywhere? No, you want that in memory. So Redis is in memory, fast, key value, use it. All right? And there's a lot of other really cool data structures. For example, this one right here, a sorted set. Netflix uses tons of Redis, like literally everywhere, and sort of most of the other high-flying website companies. But one of the things they do is they have about over 1 billion API calls per second. I'm sorry, per minute. It's a lot more than that, but I can Let me say that for sure. And what they do is they take all the error messages that they give them that, and they throw it at the Redis sorted set, where the key is the ID of the leaderboard or the structure. And then inside the structure, think of it kind of like a table in a way. You've got two values. You've got a value, one we call a value, which is the error message itself, which is the string. And then the other one is a score, which is incremented every single time that error message comes in. And so very quickly, very, very high performance, you can have the most common error messages right to the top. And you can write that code in like a few minutes. So productionizing that thing is a whole different story, but you can definitely write the code fast. So there's data structures here. You should look at them. They're incredibly powerful. I'm going to share one more with you. It's the bitmap or bit array, some people call it. It's a key, and then all it is a bunch of ones and zeros. That's all it is. But if you have 100 million users, and you want to know which ones are online right now, each one of those bits is uniquely addressable. So you can store the address to that bit for each user in their profile. Look up all your friends or whatever group of people you want to find who's online right now. Throw those addresses at this data structure. It will then return to you those that are currently yes or online. And so talking about microservice, that's like an awesome microservice, right? Who's online right now. And it's crazy fast. So just amazing things you can do with Redis data structures. You should definitely check them out. We're going to talk about Redis streams, which just came out 2 weeks ago. 2 weeks ago tomorrow, I think. And Redis streams is incredibly powerful. We'll talk about that more in just a few minutes. Okay, I don't have time to talk about everything, but lots of interesting things here. Another thing that's super interesting is about 2 years ago, Salvatore, the creator of Redis, was sort of like this Linus Torvalds of Redis. Want to make sure the code is, writes most of the code, make sure it's all super high performance and clean and all that kind of stuff. He created something called a Redis module system, along with our company helping out, and we built the ability to put your own logic into a module and then plug that logic into Redis. You can extend Redis with your own data structures and your own logic. So very powerful. Here's the ones that are currently available to you. There's a few more that aren't here, but Redis search gives you the ability to do essentially what Elasticsearch does when you do Redis in memory. Redis ML is one where you can do very basic, random forest type of machine learning processing. Redis graph is sort of like Neo4j type of thing, where you have social network type graph. In Redis, JSON is kind of like MongoDB, where you have a document store with JSON data structures, and then it indexes the fields for you, et cetera, et cetera. So there's really cool stuff you can now do in Redis. Makes it much, much more than a cache, much, much more than a key value, much, much more than what it's already been doing. It now can do other types of database capabilities, and that's why we call Redis multimodal, because it can do all sorts of NoSQL type things. There's even Redis SQL, which I don't know if it's up here or not, but you can do SQL in Redis now too. Okay, so very quickly, we're going to talk about some use cases. First of all, microservices, microservices, microservices. Everyone's using Redis with microservices. Literally, Redis is like almost everywhere in here. And pretty much everywhere you go where they're using microservices, you see lots of Redis. Why is that? Because each microservice is kind of like its own application. Right? I don't want to get into one of those microservices, but just think of it like its own application that's serving other parts of your company, and each one of those applications has its own API. It may not even have a web interface. But each one of them has its own database usually, and that it may need data from other microservices. So quickly, you think, well, if I need data from other microservices, maybe I need to cache that data. What are you going to cache that in? Redis. Now, if other microservices need data that you provide, what ends up happening is you're constantly looking up, okay, I'm caching some data from microservice 1, 2, and 3, and now that data, I'm going to let it expire after 5 seconds, 5 minutes, 5 hours, 5 days, whatever. But then you got to go ping it again, right? Every time, what if nothing changes? That's a lot of extra traffic for nothing, right? So wouldn't it be nice if you could use something like PubSub, where you say, okay, my data has changed. I've got 3 other microservices out there that want that data. And how do I get it to them? Well, I can have them come and ping me all the time and bother me. Or I can say, here you go. Here's a notification. data has changed, come again, right? So that's what Redis Streams is going to be awesome for, because you basically have all those other microservices subscribe to the changes in your own microservice, and then they'll get a notification saying it's changed, and they can come again, right? And I expect this to be extremely popular. Okay. Tons of other use cases. I don't want to bother you with too much of it, but cache, session management, metering, like rate limiting, that kind of stuff, fast data and ingest. Definitely use it for session data. There's lots of reasons why you want to use it. You're basically going to set it up as its own database and relieve your primary database that you're using. Redis is super easy. It's just commands. That's HM set. That's going to set a key called user session import 1. In Redis, it's just one giant index. So you typically will prefix your keys with sort of a namespace for your keys. So it's kind of easy to understand where your keys are. It makes them both human readable and super fast. And then this would be passing in field value, field value, field value. This is again how you might set up a session for your web app. Okay, again, lots of other use cases for metering. Companies like Home Depot, they actually, they have 2,000 apps all hidden in their SQL database cluster because that's where they call the data, and they just can handle the peaks. So what they did is they put Redis in their data layer, and every single request during peak time goes through Redis and says, does this app have the right to continue talking to our database? If it doesn't, if we're at peak load and I need to rate limit, I'm going to delay the request by up to a second or so until the traffic dies down a little bit. This is how they actually spread out some of the load. But every request to the database goes to Redis first. Why? Because Redis is sickeningly fast. Okay, and for data ingest, one of the primary use cases originally for data or for Redis was ingesting a whole bunch of data. All right, so let's move on. Redis streams. Now, I don't want to spend tons of time on this, but I do want to help you understand what it is. So first of all, this is something that has been put in not as a module, but as core functionality in Redis. It took Salvatore about a year or so working on this heavily to come up with this, and it was actually in beta for quite a long time. This is I'm not sure if it's a .0 release, so you know what that means. There's probably some things that will be found, but this is a legitimate first-class citizen within Redis. And if you're not familiar with streams, streams are really built around things like logs. You have lots of data coming in. There's some sort of timestamp or something to it usually, and what you want to do is you want to capture that and let those applications or services process the data at their own speed, so that you're not waiting for them before you respond back to your client and say, okay, the data's been processed. You capture the data, you respond back to your client with the key and most important things, but any post-processing can now be captured and performed by the Redis stream, and then other client applications or services that need to then process that data, but you can, in the meantime, move on. And if you've used Kafka, it's kind of in that category. It's not Kafka. It's done in the way you would expect Redis to behave. But it does perform a lot of the same types of capabilities. So you might say, well, if there's Kafka and others out there, why would we do this? Why would we recreate something that may already exist? Well, again, there's nothing that's really been done the way Redis would do this. For example, Redis already has this concept called PubSub, where you can use the list data structures to create consumer groups and folks can subscribe to data, but we call that really fire and forget. Where the data comes out, you send out a notification. Think about like your phones, you got those little icons with a little red number on it that says you got 10, well for me I've got like 50,000 unread emails, but you get the idea. There's a number that shows up there. Well, the notification to tell it to increment might be a fire and forget PubSub notification. And is it really the end of the world if you didn't get that little increase because your phone was off or something, or the network went down or whatever? It's not the end of the world. But it works for that use case. Very lightweight, messages go out, hopefully you get the message. With something like Redis streams, what happens is that data, that notification goes out, But if the consumer is not available at that time and comes alive or wakes up later, it can then go back and check with Redis streams and say, did I miss anything? And it will keep a historical record in the stream of what data has changed and even a locator of where that particular client left off. So when the client comes back, it will then see, okay, here's where it left off, and it will continue then reading the log from there. Therefore, the client doesn't miss anything. Okay. Okay, so I'm going to keep going here. One thing just to keep in mind is that you typically have one producer creating the log, but you can have multiple consumers. This is more or less how you should think about Redis and streams. So it's creating like this starts here, it starts adding, and then you might, actually, yeah, so then you can pull off the list. I'm not sure actually which way this is going, but you can pull off the list from the starting with the oldest first. And particularly if you're interested in details about how this works, every entry has its own unique ID. These are typically globally unique. So what they're trying to do there is actually create a unique ID no matter how many consumers or producers there are. And one of the ways we'll do that is you tell the server, you create the ID. Okay? Or if instead you say, I want to create that, you can go add an extra value to the end of it there to auto increment. It's a little more complicated than that, but that's the general idea. And you can add lots of different fields to it, so it doesn't have to just be, you're not limited to a number of fields. And you can pass in many at one time. So you don't have to make a round trip for every single row. You can actually package it up a whole bunch and send them all at one time. So it's very, very highly performant. And while I don't expect it to be as comprehensive as Kafka is right now, Kafka's been around for a while. It's got lots of different features that Redis doesn't have. But if you think about how Redis typically works, it's typically lighter weight and very fast. And Redis Streams definitely does that now. I don't have time to get into all the code, so I'm just going to keep going through this. But you can basically, well, let me just show you. You can basically, add entries. Again, you can add multiple at one time. That star right there basically says you create the key, the timestamp. Okay. You can add multiple field values, etc. And of course, you can iterate through them from the consumer side. You can do a block and then a read. And you can do multiple at one time. Okay, so let me just show you a quick demo. I think it'll still capture this. All right, so what I have here, okay, it doesn't like that. Let me see here. Oh, if I get out of this, maybe it'll work. All right, let's see. There we go, okay. So what this is, again, I'm gonna go fast. I don't wanna bore you with all the tiny little details. Plus, I don't really know all of this code anyway. But what this is this is a sample app that we created that a guy named Roshan, who's actually speaking at the Silicon Valley Redis meetup on Monday if you want more details about this app. What it's doing is it's pulling in Twitter data. So it's pulling in a Twitter stream and just simply throwing it into Redis streams. And that's the first part of it, right? So let me just show you this, for this part running. Let's see here. Okay, these are, there you go. You can see the data coming in, right? And let me stop that. And again, you can just see that it's basically creating a whole bunch of fields. Whoops, okay. Oh, I think my other one's running too. Maybe I didn't turn this one off. Okay, let me go back over here. Hold on. Okay, so it's just pulling a bunch of fields. It's pulling in things like the timestamp, it's pulling in the ID of the tweet, it's pulling in the person's Twitter ID, you know, they're pulling in the number of followers they have, you know, all that kind of stuff, pulling in a lot of information about the tweet itself. It's throwing it into a Redis stream, right? It's coming in fast, okay? But we know we can just dump it into a Redis stream. Now, what we also have is we have a consumer that's looking through these streams, and it's looking for folks who are tweeting who have a large number of followers. So, like influencers, okay? So, in this case, we're looking for followers that, or influencers that have over 10,000 followers, okay? Now, that code needs to pull the data out and parse through it. And so those are the subscribers to this stream, or consumers of this stream, okay? And that's a separate client or set of code. And let me get that going here. Okay, I believe it's this one. Yeah, okay, so you can see here. All right, what's happening here is it's looking for new tweets, okay? And when I first ran this, it went through the stream that had already been generated in the first service or app, the producer, all right? And it processed all of those looking for influencers. It took them out and it dumped them into a different data structure. Actually dumped them into the sorted set data structure, because that's how you quickly, very easy, in real time, get a top and bottom leaderboard of influencers. So this is basically 10 of the top influencers. And right now it's waiting. It's saying, hey, there's no new, the producer is not creating anything for me, so it's just waiting. Now what I can do is I can stop this, and I can go back to the first one, run it. Okay, now it's producing again, right? And now I can go back to my collector and run that. Okay, so it's going to look through the stream. Nope. Okay, well, I didn't do a good job of showing this off, did I? But basically, it is, as a consumer, it's able to then see that there were new tweets in the stream and then update the list. Yes? Yeah. Okay, here you go. I think out of order events. So I don't know if I can answer that, to be honest with you. But if you can describe the problem one more time, I think I might hear you. So
for example, if we have a couple of
right. Right. Okay. So they're coming out of order. So so if I know that if you have multiple, so I think in our case, according to what I understand, there's one producer. So I don't know if you can have multiple producers sending into one stream. So maybe that's. It looks better. Yeah, please try, because I know the answer to this, but I'm not. So yeah, say there's one producer. The producer sets the timestamp of each thing. It gives you timestamps on order. Right, it's in the order. Yes. So okay. So I answer that. So yeah, there's one producer and it sends them out of order. Redis will be clever enough if in the submission of the data, the information is there to tell it in out of order. That makes sense.
Most of these systems have things like watermarks or windows in which they will reorder. You're beyond that window.
I don't, that's a good question. I don't have the answer to that.
So wait, yeah, and Redis is going to go for it. Oh, so Redis, what happens is you have timestamp flow and lines, Redis flows and together timestamp. But if Redis considers the timestamp to be higher than the latency, to reject that. So you cannot generate a message with the lower timestamp. You know, those guys don't want the message to be you have to look at the layer. Redis allows you to make as a lot of structure to allow so you can store it to the registry, you have to do that. But it is possible to store it here. The registry data structure doesn't have an example of integrating or processing of the text, but it should be sequential in order.
And so to add on to that, the way I would solve
the problem that you're describing is to actually use that timestamp that's coming from the source in a sorted set. A sorted set on its own guarantees will sort the data. I'll still insert the data into the stream, and the sorted set basically just reference back into the stream, basically point to the stream as a system reference.
So is that a way to compensate for that?
Well, just a way to solve the problem. I mean, there's no the data structures in Redis are the reason they're pictured as labels is because of building blocks. Not one of them does not solve all the problems. And so what you typically end up doing is using a combination of data structures. I have an example in my little bit of those. But basically, leverage the power of each data structure to solve a piece of the problem. And it's the combination of data structures that ultimately solves the problem or delivers the solution.
So, if you have any answer your question, let us know your information you get back to this. It's new and some of us, especially, are still learning on this. Yes. Different question. Yeah. So
this comes up in so the workflow I'm actually interested in is open sourcing.
Yeah.
So in this case, I'm doing transactions to Redis database. And I want to automatically commit the transaction and write events to the stream.
Yes. That you don't do. The way in which you do that is with something called multi. So there's a command called multi. So it says I want to submit these commands in order. And you just write it to a single thread. During that period of time, no other interactions can occur. So you know that those will occur in that.
Well, there's a permanent order, but I only want the right to the stream if the transactions succeed.
You can also do that. I'm not as up to date on exactly how you do something called a watch.
Yeah, so basically a combination of multi-executive watch. So you know the multi-executive occurred, and then you proceed to
It's not quite a transaction when you typically think like this database, but what you're doing, you're saying, I want to do this, but only if that didn't change.
Yeah. I mean, we can use the workflow, which is if this database gets updated, we want to commit something to a stream so other people know what happened.
Right. Yeah, that's how you do it.
The actual web design pattern is called event sourcing.
Yeah, honestly, I know about event sourcing pretty lot of Chris Richardson and those folks. But I haven't gone through all the examples of figure out how to do it. But with this example, I think that's fine. In fact, just a quick comment, I was talking to Chris Richardson, who is the creator of something called Benchling, which is a library and a service that does this kind of thing. And he said absolutely Redis can behave as the database behind that. But you still need that logic that you're talking about. And I don't think with Redis by itself you would get all of the features you're talking about. But if you use something like eventually on top of it, you should be able to do it. If that makes any sense. Yeah. Okay. Yeah, and you're probably more familiar with it than I am, but I definitely had that conversation with Chris just like 2 weeks ago. And hopefully we're going to do something about that.
Okay. All right. So you get the idea with this demo. If you have any more questions about it, please, again, we're still, well, especially me, these guys know more, As far as details of how these things actually get implemented in detail, I definitely don't know how they but I know people who do. Okay, so with that, let me see. I think I had one or two more things to say, and then I got to move on here. Oh yeah, so where are we at with Redis streams? So it just came out 2 weeks ago, and so thankfully there's already people who've been using it in pre-GA, so like release candidate 1, 2, 3, 4, and 5, that have already written lots of code. There's lots of samples already out there, probably in programming languages. I just saw some in Python. There's definitely some in. No, there's languages. Lots of samples out there already. Closure, yeah, there's lots of them already out there. So you should be able to find what you need. Redis Labs has something called Redis Cloud that runs on all the major clouds, Amazon, Azure, Google, IBM, etc. So we run Redis as a service for you, and there's over 50,000 databases running in there. We're very good at it. And that will come out later this month. So you can actually use it as a service. You don't have to set anything up. You can just point your code to a Redis cloud instance and just use it. We also have enterprise software, and again, later, let's say this month, I think it's like already November. So in November is when they'll come out, and you'll be able to get maybe early access to Redis Enterprise as well. That's the software, but you can definitely be able to try it out as a service in Redis Enterprise Cloud. And of course, you can try it out. The example that I just shared with you, you can find out this is Roshan, this up here. It's just a GitHub repo called Redis Labs demo. It's something he put together. And then I have one that later on I'm going to show you that's called Redis DL demo in my own GitHub account, D. Nielsen. I'll share this with you later. All right, so we're going to move on now because we have the Redis Edge to talk about. And Rob, come on up. So Rob is our VP of IoT and Innovations at Redis Labs. And and so he's been working with us now for most of the year to come up with how Redis fits into not just the Edge, but other IoT type situations. And so what he's going to talk about now is something called Redis Edge, which is a product that we're coming out with to help you run Redis at the edge. So let me. Okay. Right. Ooh, okay, 20%. Okay, here we go. No, it's okay. I'll plug it in. Okay. Just never mind me.
Okay, thank you all for coming. I appreciate it. I'm going to bring it up a couple levels, just to let you know, because now everybody raised their hand to know where this is, and now you know where the stream is. And I'd like to share with you something that's pretty cool that we're doing with Redis streams around IoT in particular. So a product called Redis Edge is essentially open source Redis. Version 5 related has to have streams. So streams are key enablers for what we're doing with IoT Edge and Redis Edge. And it's inclusive of modules which are common at the edge. Things like deep learning, things like graph, high-utility database, these things that we see all over the place that are necessary capabilities for a multi-modal database at the edge. Very key is, I see a very, very wide and diverse set of compute storage environments at the edge. Everything from the Raspberry Pis, 132 devices, to high compute storage like robots or the device. So it's not like a typical deployment to a core data center or cloud. There really is a great amount of diversity. You may have to have a very small footprint. So whereas Redis Enterprise may be awesome for cloud-based IoT solutions and many other applications, at the edge is something that's more like open source code, less than 10 megabytes, and run on R32 multi-platform. You know, obviously 64-bit, 32-bit, x86, and Raspberry Pis on 32 devices. And the thing is, at the edge, what we're seeing is a massive shift of computing, we call shift left. You know, a lot of computing in the last 10 years shifted to the cloud because of critical latency requirements, because of bandwidth, because of locality needs, and so forth. We're seeing distributed cloud computing at the edge of the network, at the edge of the service providers. And so, consequently, with limited storage, limited compute at the edge, we have to have something which is lightweight but also extremely fast, able to ingest millions of bytes per second, sub-millisecond latency. You know, we need to be able to do real-time processing. We need to have tunable persistence. Many of these applications require persistence at the edge. And we need to have multimodal. I'll show you a couple of examples of applications that we're doing at Redis Edge where multimodal is very, very helpful to have. And so this is so big up here. So this slide is an attempt to show Redis Edge fitted into library types. So the left hand, you have the devices. Across the industry, you have the gas, you have manufacturing, transportation, healthcare. You have IoT at the edge in all of those industries that have different kinds of form factors of devices, sensors, actuators. They need to be sensed and activated at the edge, and then aggregated will go through the cloud. So where I'm really focused is in this middle section here, and at the edge, how to enable applications to get critical latency requirements and description real-time processing at the edge, not processing in the cloud. But at the end of the day, we're also seeing a lot of IoT use cases that have hot data, cloud, so you need to be processing as well for major work you can. And that's where I think Redis is the most strength. With Redis Edge at the IoT edge, and the Redis Edge or the instant report. So just briefly, I'd like to share a couple of examples of how we're using Redis Edge, which is enabled by Suite, and how we're trying to activate that in the IoT edge. Probably most of you, possibly none of you have heard of EdgeX Foundry. Okay. But EdgeX Foundry is a Linux Foundation project seeded by open source code from Dell. It's growing very, very fast. Okay, so it's open source, open community, trying to make something which is very difficult for hundreds and hundreds of people trying to develop applications and trying to make it easy in providing open source staff that you see here. The purple layer being the data area for services, where we do most of our integration for data, IoT data, and sensors, metadata, data about the sensors, as well as the registry configuration data, and the export data, going around to cloud or to the environment. So Redis is embedded right now inside EdgeX core services. So we have a number of companies that are doing commercial implementations on top of EdgeX that would like to use Redis and Redis Edge as part of their implementations. So this is real. This is existing, embedded into EdgeX. So lots and lots of application developers can come and develop on top of EdgeX, and they'll find Redis immediately right there as part of the core services that they leverage. But by pointing out multimodal, this is one example where you can see that because it's a single Redis Edge, you need to provide all the different data services for the applications developing on top of EdgeX. The other example I'd like to share is around Azure IoT Edge. So this is another example of it's a real implementation. So Redis Edge is a module in the Azure IoT Edge marketplace. It's ready to go in the runtime environment. Okay. So we're going to expose to ISVs in the partner ecosystem, and the enterprise sales, and bundles. So basically, we're trying to have Redis Edge integrated where it needs to be. Where it needs to be data that exists out of the cloud. People go to develop applications, and I think Redis is a perfect fit. We allow you to integrate Redis and fitting performance, lazy fast performance, very lightweight, very flexible with data structure that the data described, streams being the data structure that the recent EPA that's very, very relevant for IoT Edge. So You can see here again the need for a multimodal database in single instance on Azure Edge. You can have ingress of data, time series, egress, filtering, passing. So lots of different data services with applications from leading current queries, all of which can be provided by a single instance of Redis Edge. So I think that's all I was going to show. Yeah, I have some backup slides, but basically, I just wanted to introduce you guys to Redis Edge. This meetup is more about streams, kind of announcing the open data structure. David started the first class citizen with the data structure on a module called streams. And now streams for IoT is enabling us to do a lot of really cool things. So that's it.
Okay, next up, we're going to just have Andre, also works at Redis Labs. He's working with Rob on specific implementations and solutions. He's going to talk about Redis for Azure, Redis streams for Azure.
Yeah, basically just ripping on Rob's last slide.
Okay. More examples.
Exactly. So, there was a demo, but it's crashing, so there's no longer a demo. All right. So, one of Rob's last slides was the Azure IoT Edge. So why? Yeah, cool. Why that platform as opposed to the others? And so, stole some slides from Microsoft because they conveniently help me tell the story. So the way Microsoft Azure is looking at the world is there's IoT in the cloud, and that has a purpose in life. And then there's IoT at the edge, or on the edge, and that has a purpose in life. And so when we look at that, we're like, for us, this is perfect because as Rob was describing, when you're working at the edge, you need a really small footprint. You need to be super fast because these devices are throwing out data at incredible rates, and so you need to be able to ingest and react to that data at those rates. And then when the data moves to the cloud, you need to be able to scale, and you need to be able to handle large quantities of data, still in real time, but at much larger scale. And so this, the core message around Azure aligns perfectly with the kinds of stuff that we want to do with Redis. So let me just do the entire build here. So when so what the hell is Azure IoT Edge? If you don't read too many words, but just sort of read the bolded ones, it kind of sounds like Docker, right? I mean, they kind of injected a couple of words in for themselves, but they don't use the word. They use the word image, but they don't use the word container. But in effect, what Azure IoT Edge is doing is it's creating a model where you're using effectively Docker containers to create what they call modules, so that you can create IoT building blocks. And so on here they're talking about a device in Germany, a device in China. These are modules, and you're basically adding a little bit of runtime, putting it inside of a Docker container, and then doing an integration with a device, a sensor, video camera, could be anything. But it just sort of lends itself to a really neat architecture, which ends up, just do that. Entire build here. So it ends up a deployment on Azure IoT Edge. Basically, it looks like this. You have, in this case, 3 modules, laundry, insight, action, whatever they are, sitting on top of a runtime. But from a developer perspective, you've either developed or you've purchased or you've downloaded these other modules. You've grouped them together into a deployment, and Azure IoT Edge is taking care of getting it out to a virtual host, physical device, whatever it is that where the stuff needs to run. So it creates just a really easy way to build solutions. And again, if you think about what we built, what we bring to the table, we're bringing really fast data ingest, really fast reaction to data. We can become a module. We can plug into this and add value, basically better together, right? Add value to this overall runtime. Coming back to the point that Dave was making, we get to create building blocks for data ingestion and persistence at speed, right? So take advantage of this infrastructure by adding a module to it that adds these values. Leverage the data structures that Redis has. So we've been talking about streams a lot, but there's 10 data structures in Redis, and they all have value depending on the solution you're trying to create, whether it's an IoT or risk management. So a bunch of data structures to build on, and on top of that, we can add higher order value around machine learning, deep learning, search, organizing data around time series, just by plugging this Redis module into this overall runtime. So we were looking at this and saying, wow, this is really exciting. And so, of course, in order to, what's the next step at that point? You need an architecture. So Chris on here is a program manager at Microsoft. And we basically got together and said, if we were going to just do a really quick POC, what would this look like? How could we just plug this in? And Chris says, well, I got a video module, and I got a machine learning module. And I said, well, I can knock out a Redis module for this. And so architecture. And so what does this end up looking like? So kind of coming back to what Dave was touching on in terms of leveraging streams. When we're ingesting, so sorry, I should go back and actually describe this. So the use case is a video, some sort of a video camera, or in this case, a fake video camera, just a video stream. We ultimately want to recognize something. The demo was apples and bananas. Not very exciting, but that was the before that we had to test this with. And we had a model that already knew how to recognize an apple and a banana. And what we want to do is leverage the data structures for Redis, not only for capturing the raw frames, but also capturing when something's recognized and when other things had a high probability of being something that wasn't necessarily recognized. And so the idea was to make Redis the system of record of all the knowledge, so basically raw information and recognized information. The system of record for the entire system, so that some set of apps could do something with it. Maybe just display it, but the idea was that it could be, these apps could be doing anything with that collection of data. So what does this end up looking like? It's actually really easy. So what's frame ingestion look like? I mean, literally, imagine that your data is coming into a log file. You're appending data just onto the log file. The next frame is just the next entry in the log file. And then on the other side of it, once it's been, remember my picture where it was video and Redis and machine learning? Once it's been recognized as an apple or a banana, there's two new stream data structures. One, if the thing has a high probability of being an apple, add that this frame had an apple in it, and same with a banana. So now I have end up with three data structures, all of them streams. One is the raw data, one is all the recognized apples, and one is all the recognized bananas. And then on remember the diagram with the app at the top? What's that consumer doing? Well, it's treating it like a time series data. So show me, 30 seconds, show me all the apples that were seen in the last 30 seconds. So that one data structure gives me, we keep using this word I want to say multi-model, but it's multimodal, thank you. Multimodal. Basically what we're saying is, you're not forced to look at data in one way. You can take advantage of these Redis data structures and look at data as appropriate for the application. So here I'm basically treating this unified log as time series data and grabbing 30 seconds worth of data out. So in terms of Azure, that's sort of a rough sketch of what that implementation looks like. But what I thought was interesting was when I did the EdgeX implementation, Redis Streams wasn't available yet. And so it wasn't that I couldn't implement a time series kind of lookup, it just was harder. And this comes back to the comment earlier about there's all these data structures in Redis, but no one data structure solves all problems. You end up combining data structures to solve problems. So, so in the EdgeX case, where I don't have streams, what I end up doing is using a sorted set and sorting based on timestamp. So if I need to grab a certain time range out of a set of events that come from devices, I go into the sorted set and basically look for that range, because the sorted set guarantees that everything's kept in order based on that sorting value. So still accomplishable, but the point here is you will always end up using multiple data structures within Redis to solve a problem. So what's next for me in terms of the Azure IoT project? Apples and bananas are a lot of fun. License plates are where it's at though, because I want to do something that's a little bit more visceral for someone who can say, wow, I can watch cars entering a parking lot and figure out how much to charge them when they leave. I can build a metering app on top of Redis. Hell yeah, you can build a metering app on top of Redis. Right now, we have a very low-res video stream, and we store the entire frame in Redis itself, which if you had a high-def frame, you probably wouldn't want to do that. So what I want to do is add a content management system, store the raw data, the raw video data, basically the video frame, in the content management system, and then only store metadata back in Redis. Because again, it doesn't make sense to have a high-def frame directly in Redis. During the time when we were implementing this, our team over in Israel has refined our own TensorFlow implementation. So we have Redis DL. So I think I should be able to drop in, replace that Azure ML with Redis DL. So I think that would be a good thing to do. And then this is all running on virtual stuff, right? This is all VMs and virtual devices. Someone pointed out to me that I really should try to run this on a real device. So hell yeah, I want to run it on a real device. What I really like about this use case, going back to my architectural picture here, what I really like about this use case, this pattern, is this component over here, it's just a sensor, right? This could be, sure, it could be video, a camera pointing at at the entranceway to a garage and showing license plates. But this could actually be a handheld where you're walking around an oil rig and your model can recognize safety flaws in in the rig, around bolts, around connectors. So this pattern just becomes really exciting in terms of other use cases. And it doesn't have to be video. It could be a vibration sensor. So now we're talking about monitoring vibrations in turbines. And 3 boxes, brilliant architecture, but kind of a neat pattern for doing other things. And this would be where the demo happens, but as we know, demos crash. So no demo. That's all I got.
Great. Okay, we're almost done. Now, okay. So Andre just mentioned Redis DL. I'm guessing none of you have heard of this. Has anybody heard of Redis DL? So this is something that is in early beta. But if you know anything about TensorFlow, you may know about something called TensorFlow serving. TensorFlow serving is the library that they call it. It's basically the file that allows you, that you run to actually serve the models in real time, right? Or serve the models to be able to train, predict or store or whatever the data coming in. And what's nice about it is it's written in C. And guess what? Redis is written in C. And guess what else is written in C? The Redis module system. So that means that we can take TensorFlow serving, incorporate that into a Redis module, and load that into Redis. So now we can take models created using TensorFlow, import them into TensorFlow serving, basically the network, and put that in Redis. Now, if you have the ability to put a model into Redis to be able to score in real time, and you have something like Redis streams, now what you have the ability to do is, as the data comes into Redis streams, you can score it in real time without having the data actually be in Redis. I don't know, maybe there is a way, but I don't know how you get faster than that. See, it's all in memory, it's not leaving, it's just scoring everything as you go. I'm sure there is a way to do it faster, but it sounds pretty good to me. So anyway, what I wanted to just quickly show you is that, by the way, this demo, I'm not even sure it's going to run because I whipped it up at the very last second here using somebody else's code. And I'm not going to recommend you do this. But let me see here. Okay, hold on. So you kind of see this code up here. Or the files. So what it is there's a middle file and graph. And you can take that, you can actually generate your model. Or I guess not the model, but the network. So you can train your model using the data. But that you would do in TensorFlow, right? Then what you can do, and let's see here, you can then, gosh, this demo is going to be terrible. Oh, let's see if we're going to run. Okay, there you go. All right, so then what it's doing is actually scoring. Now, in order for this code to actually work, it's actually making a call to Redis with with each one of the data points. And it's all you do is predict the square root. This is a very simple one. That's all I can figure out how to do with even help. Consider that in much time. But what it's doing is previously in the other file, I took the graph and it submitted the data and it trained on that data to come up with an algorithm in TensorFlow to predict the square roots of values. And you think, well, that's just math. Well, no, you feed it which data. That's trained on itself, figure it out. And now what we're doing is we're just passing in numbers and it's then predicting the square root of those numbers based on the historical data. Okay? And the way this is working is this file that I just use submits the value to Redis. That value then gets put into, in this case, it's not using strings. It's just passing it into the Redis DL module, which is then calling a TensorFlow survey, which has that model in it. Okay? And then it's able to score and return back, in this case, value. That's how it works. And all I wanted to show you, and I don't have time, and I can't even explain it to it myself, but I wanted to show you that this works. Okay? It definitely works today, even though it's early. And if you want to have access to it, okay, this is the code right up here. And I have some very basic instructions that I haven't actually gone through and tested yet, but I put them up here based on my own experience. And and so here you can see the TensorFlow file that created the model, and then you can see the Redis code, or the Python code that calls Redis to actually process it. Okay, so again, not a very powerful demo, but just to show you that this actually does work. Okay, and all I needed was TensorFlow serving, needed Redis, and we need the Redis module, Redis DL module. And that's the power of modules, is it gives you the ability to extend the functionality of Redis. And again, in certain use cases like this one, we have streams coming in, you don't have to have those streams leave Redis to be able to store them or predict in real time. So use cases, a couple of different use cases that I've already heard of. Number one, detecting attacks on your network. You have a sequence of network logs, and you might have 10,000 of them for 30 seconds or something like that. And you can then have your model train on windows of data, and then look at that window and try to predict are any of these patterns looking suspicious. Another one is a friend of mine, coincidentally, has a startup that is a baby camera. You might think, well, what does that have to do with baby camera? Well, what they're doing is they're just playing around with this thing. They haven't implemented this, but they think this is a good idea. Because what they're doing is they're actually streaming video from the baby camera to the cloud, where they're analyzing each frame to see what the baby's doing. And I have a baby. I have a 8-month-old baby, so this is something I'm using. And so what happens is each frame gets sent up, and it's amazing how even though they send, I think, only 10 frames per second, they can actually see the outline of the baby, they can figure out where the stomach is, they can see where the chest is, they can see the breathing. They don't put the red line right where the breathing's happening. They can see as your baby breathing. Amazing. The way they're doing this is they're setting the frames. It's only 100K frame. Each one is a command to call out to Redis in the cloud. They're actually calling directly from the client, so directly from the baby monitor. That's pretty interesting. Using certificates, so it's secure. And once the frame actually gets to the cloud, that's when they're able to use their own trained model to then evaluate it frame by frame. Pretty cool. And they have that's a couple of their special sauces. They build their own algorithms for this kind of stuff. And then what they do after they've done that, they write on the, I'm not sure if they actually put it in here themselves or just pass it coordinates, but then that which you can set down to the clients, which is your mobile phone, and no matter where you are, if you have an internet connection, you can then see your baby breathing, you can see, is it awake, is it in a crib, kind of important though. All these kind of interesting things. They can even predict things like, is your baby wet? Is it hungry? Because they can kind of look at patterns of eating, that kind of stuff. Really interesting stuff. So that company is called Cocoon Cam. Go check it out. They've been around for a while. They're very money and they're doing quite well. And again, very interesting use case. I think that Redis is being something that's just data, but no, absolutely, it's not real saying Azure for IoT, and this particular use case you definitely need to data to your frames. So that's all I have for you today. Hopefully you've gotten some inspiration, some ideas. Redis streams is brand new, lots of opportunity to use it in interesting ways. Redis and TL is like ridiculously new. Get involved with that if you'd like, and probably do something nobody else has ever done. So if you're interested in any of these ideas and you want some help, contact me. I'm not going to do the slide right now. Dave@RedisLabs.com. Okay? Dave@RedisLabs.com. I also run the Silicon Valley, one of the organizers of the Silicon Valley data group and the San Francisco data group. So you can contact me that way. And I'd be happy to give you sample code. Get you involved in the early days of ResDL, help you answer any other questions, connect you with people like Andre and Bob. That's kind of what I do. So that's all we have for you today. And I'm going to do some t-shirts in a minute. So stick around for a t-shirt. I'll be first carding to those who filled out a card put in there, and then shirts left over. Any questions before you go? Yes?
How big a video frame have you used in this series?
So I don't know the answer to that. What have you done?
I did put an HD frame in, but it doesn't make sense.
I would say I have my 10 megapixel camera. I'm sure you have to try it.
Not 10 megapixels.
I don't think we can. Well, let's see. You can go to. No, you can. I mean, you can go
Yeah, it's not a problem. But it doesn't make sense to me to think of it as a scale. Why would you consume memory from your memory database or something that ultimately just 10 megabytes is a tricky one?
Yeah, actually, I would say you might be able to do that. Every time I keep thinking about how big that's too big and something completely wrong, you absolutely might be able to do that. I know that the maximum per key is 360 megabytes.
Yeah, no, I'm saying. On your screen. It makes more sense to put that as data.
Yeah. So 512 megabytes is the maximum. Okay. So, I know what saying. So there's the web. This is company in China, by the way, people in China use ridiculous amounts of reps. Insane amounts of reps. Like companies have like 2,000 developers all just building out. Crazy. When you think about the scale they have, Tencent, most popular website on the planet is the single person day, whatever, how they had it, with like loads of doors for anything out of and thousands of other servers. What I was going to say is that one of the companies is a video streaming company using HTML video, I forget exactly what that's called. HTML video is standard browser format. And they take all the frames and put them on an object store. Here in the US, we use 3. And put all the frames, so frames are all static. And then what you have is all the metadata about what frame comes next in Redis. And that's how they're serving it. So I mean, there's all sorts of interesting ways in which you use, and they're ridiculously scale, incredibly lightweight. I don't know how they do it, but that's how they figure out like what frame comes next, and actually talks to Redis, gets that information, sends it somehow down to the browser, and the browser pulls the frame, the video frame from wherever.
So, okay, lots of interesting use cases. If you have any interesting use cases, I love to hear them all the time. Let me know. Otherwise, we'll come back. And stay around for sure. Thank you very much. Just make sure people put their cards in the right. So, if you put your card in, come on. This is it's nice to see you. I promise. Yeah.